Hey guys, this is Dr. Callahan with week 17 Thursday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for your warm-up log. Okay, so this is actually our second to last week before your AP test on week 19 Monday. So let's go ahead and take a look at one of the questions that I find is oftentimes a repeat of a lot of the questions that appears on the AP exam for the free response questions. Particle motions are very popular for some reason, and so I feel like this is like the 3rd or 4th time we actually gone over this question or something similar to that. So this is one that is number 2 with a calculator on the 2019 free response question. So take a look at this one here. 4 parts. All right, let's go ahead and try to tackle this. So on the first part of this, I'm looking at it and it says that the velocity of a particle P moving along the x-axis is given by the differentiable equation V sub P, where V sub P of T is measured by meters per hour and T is measured in hours. So select the values of V sub P of T are shown in the table above. So hours, meters, particle P is at the origin at time T equals 0. So from 0 to 4. So then in part A, asks you to justify why there must be at least one time T in between 0.3 to 2.8, at which the first derivative V prime of T is an acceleration of particle P, which equals to 0 meters per hour per hour. So looking at this part here, one thing I'm thinking about is with the mean values theorem, in which case there are certain conditions. One is that V of P of T must be continuous, as in there's no breaks in between that. And also V of P of T has to be differentiable, as in you're able to find a derivative. So by MVT, the means values theorem, V prime of T is equal to, since the 2 points that we're using are X sub 1 is 0.3, X sub 2 is 2.8, and your Y sub 1 is 55, and also your Y sub 2 is also 55. Let's go ahead and take a look to see what this is going to give us. Okay, so remember, this is really just a slope formula. So change of Y over change of X. So I'm going to do V of 2.8 minus V of 0.3 over 2.8, which is the X value, minus 0.3. So V of 2.8, as you know, the Y value is 55. V of 3 is also 55. And then, of course, 2.8 minus 0.3 is going to give me a 1.9. When in the numerator, it's a 0. So therefore, V prime of P of T is equal to 0 as well, which helps me in this situation because it asks me why does it equal to 0 per hour, and in which case it does. So if you're to justify this, you can say something to the effect that I am using the mean values theorem because V of P of T is continuous, and in addition, it is also differentiable. So then by the mean values theorem, you're finding the V prime P of T, which is a change of Y over a change of X. And given that the change of Y has the same numbers of 55 meters per hour, therefore, V prime P of T is equal to 0. Okay, let's go ahead and take a look at part B. It says use a trapezoidal Riemann sum with 3 subintervals, and those are the 3 they're giving you, to approximate the value between 0 to 2.8. So 0 to 2.8, it's a trapezoidal Riemann sum. So normally when you have a trapezoid, your area of a trapezoid is 1/2 height, base 1 plus base 2. But remember I told you guys you're going to have to rotate this a little bit. So then you have height 1, height 2. Your base is now here. So your area is 1/2 base, height 1 plus height 2. That's important to know because these values over here with the y's, those are going to be your height. The hours are going to be your base. So then looking at this here, let's go ahead and set this up from 0 to 2.8. Vp of t dt is going to equal to, since this is a 3 subinterval, it's a trapezoidal Riemann sum, let's go ahead and find the base. So the base in between 0 to 0.3 is 0.3. From 0.3 to 0.7 is a 1.4. From 1.7 to 2.8, it is a 1.1. And given the fact that we're only using 3 subintervals, those are the 3 that we're going to be using. Okay, so then looking at this right here, 1/2 is going to be for all of these values here. So let's take a look at the first trapezoid. So trapezoid 1 is going to be 1/2, which I have right here. And you're going to have base, which is 0.3 times height 1 plus height 2. Now your first height is going to be 0. Oh, my pen just stopped working. Zero. Height 2 is 55 plus 55 plus trapezoid 2. 1/2 is still there. So then you need to find your base. My base is 1.4 and it's going to be 55 and negative 29. Plus the third trapezoid, which the base is 1.1 and the 2 height is going to be 29 and 59. So negative 29 plus 55. And close that. Okay, so then with your calculator, because you're allowed to use one, you can say that this is equal to 1/2, and then you'll have 0.3 times 55 plus 1.4 times, I actually don't have a calculator, so 50 minus 29 is going to be 11. 11 plus 5 is 16, plus 1.1 times, and this will be 16 as well. So ultimately, when you plug this into your calculator, you're going to find that from 0 to 2.8, the V sub P of t dt is going to be approximately equal to 40.75 units squared. And this right here is your answer. All right, so let's take a look at part C then. For part C, it is asking you a second particle Q also moves along the x-axis, so that's a velocity is between 0 and 4. And there's the equation for that. Meters per hour. Find the time interval during which the velocity of the particle is at least 60 meters per hour. Find the distance traveled, so you're going to use absolute value, during the interval when the velocity of particle is at least 60 meters per hour. Okay, so then you have V of Q of t is equal to this equation, 45 square root t cosine 0.063 t squared. Okay, so it's asking you that they want this to be at least 60 meters per hour. So it has to be greater than 60 meters per hour. However, the problem with this is that I do not know what is my um, intersection with this. So if it has to be greater than 60 meters per hour, it is saying y is going to be equal to 40. And then I'm also going to be graphing this equation right here. So in your TI-84 calculator, you're going to hit graph, insert y1, y2. And when you guys go ahead and graph this, you should have a graph that looks something like this. When y is equal to 40, this is 40, so it looks something like this. And then, of course, you have your equation, which is this piece right here, and it's going to go something over like this. Your goal is to find that intersection, so the intersection where these two lines collide. Now, you know that with the first point, your y is 40, second point, your y is 40. My goal here, however, is to figure out what that intersection is. So what you can do is you can do a second calc on your calculator, and you want to put the little cursor like below that dot intersection, above it, and then it's going to basically give you an estimate of what this is going to be. You know the y is going to be 40, but what is the x value going to be? Your first x value is going to be 1.87, and your other intersection is going to be a 3.52. So now that I have this is going to be your lower bound, and this is going to be your upper bound. So then if I were to look for the distance of this, it's to be the integral of 1.87 to 3.52 v of q of t dt. So to do this, you also need your TI-84 one more time. You are going to go to math, go to 9, which is the integral button. So then when you have that, make sure you put 1.87 here, 3.52 here. Inside the box, make sure you take this piece right here, type that in, dx, hit enter, and your answer is going to be 106.109 meters. And that is your answer. All right, so let's go ahead and take a look at part D. And it says at time t equals 0, the particle Q is at a position that is x equals negative 90. So again, we're talking about particle Q. Using the results from part B and the function v of q from part C, approximate the distance between particle P and Q at times t equals 2.8. So with this one, we need to look for the distance of two distinct parts. One is position Q, the other one is position P. So in part B, we actually determine what the integral of position P is from 0 to 2.8 for the time. And we determined that to be 40.75. So we can say that at t equals 0, P is at the origin, and the integral of 0 to 2.8 v of P sub t dt is approximately 40.75 from part B, okay? So therefore, when t equals 2.8, P is at the position, which is x of P. Because remember, in order to get to x of P, which is a position function, integral v of P of t is going to give you a 40.75. So I'm going to lock this piece of information down because that's how, and it's meters. However, I need to go ahead and find the second part of this, which is finding out the distance of P. It's given to me that, I'm sorry, Q. Sorry, we just found P. This is P right here. So this is P. Now I need to figure out what Q is. I know that when T equals 0, Q is at position -90. I also have the equation for V of Q. So if I want X of Q, I will have to find the integral of V of Q. So then what I'm going to do is that at, and this is for Q, T equals 0, the position of Q is at X equals -90. That's your initial starting point. So therefore, when T is equal to 2.8, Q is at, because you're going to do the integral, which is X of Q is equal to -90 plus the integral of V of Q of T in between 0 to 2.8. And so once again, in order to find this information, you would need to go ahead and use your TI-84 calculator. So you're going to go ahead and go to Math, Integral, which is the 9 button. And you're going to plug in this equation in there. But keep in mind, you're going to be evaluating this between 0 and 2.8. So then this piece right here, you should get an answer that is approximately 44.062. So then don't forget your -90 right here. I'm sorry, that's not correct. Hold on a second. You should get 135.936. And then if you subtract 90 from that, you will get 45.936. And so this right here is your X of Q. So then looking at this, we're going to combine both of these together. So we're going to look at this piece right here, which is X of P. This is X of Q. And since you're looking at the distance between these two, so you could say at T equals 2.8 hours, particle P and Q are approximately, so position of Q minus position of P, subtract the two numbers, 5.188, and given the fact that's distance, there's no negative number, units apart. And that is your answer. So then with that said, what I want you guys to do is I want you guys to go ahead and read this link right here, or you can use a QR code, okay? And it opens up the AP Calculus AB exam tips. So if I go ahead and click on that, or in because I can't, because that's okay. Just make sure you guys use the QR code right here to access that article. Once you finish reading it, what I want you guys to do is go ahead and use this QR code on the right side to answer the question on my Padlet, which looks like this. And it says week 17. It's not going to say Tuesday or Monday. It's going to say week 17, Thursday. So let's go ahead and give that a try here. And so it will look something like this. Read the AP exam tips from AP College Board. Summarize the tips that are helpful to you. So make sure you guys do that. All right, you guys, when you are done with this, I have another question right here on your paper that is similar to the 2019 one. This is from the 2018 one. And interesting enough, this was question number 2 as well. So it seems like they just really enjoy giving out these questions on particles and velocities. And so if you need the answer for this, I have the video right here along with the QR code. As always, I hope you guys have a wonderful week. I'll see you guys next time. Take care.